complex engineering problem. Subject microprocessor and microcontroller. Topic microcontroller based digital FIR and IIR filter design for biodesical signals. Presentation by Ketat Suresh. Roll number 23951 A0224. Department Electrical and Electronic Engineering. Content of the presentation: problem statement, overview, object, requirement, prerequisites, solution to the problem statement, result analysis, and conclusion. Problem statement. Biodecimal signal ECG, EEG, EMG, PPG are after low amplitude noise prone and require the relay-time processor and portable devices. Design a microcontroller based digital filter solution supporting FIR and IIR that reliable remove the artifacts and noise while providing clinical features. Respect relay time constraint and fits within the memory CPU and power budget of typical embedded and platform. Objective: provide clean, clinically useful biodecimal signals by removing the baseline wander power line interface, the motion artifacts and high frequency noise. The support the both FIR and IIR filters implementation and guide when to use each. Ensure the deterministic relay time perform on microcontroller. Example: ARM context M series. Minimize the resources uses CPU cycles and RAM flash. Overview: this designs converse algorithm, fixed point implementation strategies, filter selections and designs, coefficients, quantizations, optimization techniques, DIMD, DMA, CMSIC, DSP, and relay time scheduling and validation using the matrix important in the biomedical signals processing, SNR, distortions, latency, sensitivity to future detections. Requirements: hardware requirements, microcontroller or M0 M3 for low power devices, analog digital converter with appropriate sampling rate, resolution 12 to 24 bit, detecting on signal, and now the SRAM for buffer and flash for code and coefficient optional, DMA hardware multiplier, FPU and low power mode. Requirements: software requirements, compiler, toolchain, DSP library, filter design tool, unit testing framework and logging tools, relay time OS or bare metal scheduler, signal sampling, target signal and sampling rates, ECG 250 to 1000 MHz, EEG 250 to 2000 Hz, EMG 1000 to 4000 Hz, PPG 25 to 200 Hz. Prerequisites: knowledge of digital signal processing fundamentals, sampling, analyzing, Z transform, frequency response, familiarity with fixed point, arithmetic, and numerical effects, tools to design and analyze the filters, MATLAB or Python, test data sheet, annotate ECG, EEG, EMG recording for validation. Solution to the problem statement: requirements analysis for signal identify target signals, sampling rate, and key clinical features. Bandwidth 0.5 to 40 Hz for ECG. List noise sources. Main 50 to 60 Hz. Baselines wonder. Choose the filter types. FIR processor. Linear phase, easily stable, simple multi-band design. Coins may require long filter length for sharp transients, higher memory CPU. Use when phase linearity is critical or when using the multi-rate filtering. Filter specification and designs. Example: band pass 0.5 to 40 Hz, notch filter 50 to 60 Hz to remove the power line interface. Design steps: use the design tool to produce the double precision coefficients and frequency response. Simulate and test signals to verify the QSR and morphological presentations. For FIR, choose the WID FIR Park MC clearances for optimal length. For IIR, prefer the Butterworth for the smooth magnitude, or elliptics for the steps roll off with lower order. Consider backward cascade for numerical. Result analysis: signal quantity matrix, signal to noise ratio, improvement before versus after filtering, total harmonic distortion for PPG and ECG if applicable, power spectral density to show noise reduce at targeted bands, group delay and phase distortion, FIR linear phase versus IIR non-linear. Conclusion: a microcontroller based FIR and IIR filtering solution for biomedical signals must balance the signal fidelity, latency, and embedded resources consumptions. Use FIR when linear phases and morphology previsions are essentials, and use IIR when CPU memory are limited or when low latency is requirement. Employ fixed point optimized. Thank you.